Then 3 squared is 9. Negative 5 squared is positive 25. Together is 34. And leave it like that. Like the option D in the handout. Or, I don't know, you put in, this 34 is no perfect square number, you put in the calculator and you get the decimal approximation. That's it. Okay, let's change the flavor now and compute dot product. Dot product 26. We have two vectors. Vector B is 1, negative 1. Remember, guys, I suppose can not necessarily repeat. Okay, we can represent like that, or you can represent like I minus j, right? That this coefficient is 1 invisible here, and this is a negative 1. Using the orthonormal vector ij, no, in 2 dimensions. But for me, it's easy. In this notation, que using angular bracket, no? And w is 1, negative 1. Wow, it's the same. They are twin brothers. And perform dot product. And remember, dot product is easy. You multiply each component. This component times this component in the same position. Okay, 1 times 1 is 1. And negative 1 times negative 1 is 1. And plus. The answer is 2. And you know, somehow this number is related with the angle in between the vector. Okay, by the way, these vectors are parallel because it's the same vector, no? It's obvious. So the angle is 0 degree. But okay. It's not important now. The important is the information for the dot product. The answer is D. Any question? Everyone follow me?
Yes, we're following you.
Okay. 27 is similar. Is B vector is 5, 0. And W vector is 0, 1. And you perform dot product. B dot product W. It's extremely important to say something. The dot product is totally commutative. So you can multiply in the order and the answer doesn't change. Be careful with another operation with the vector no. But this yes. Because you can understand that in pre-calculus we do not study everything about the vector. That the student can need more information about the vector in calculus 3, I complete the connection of the operation. But it's okay. Now it's easy. You multiply 5 times 0 is 0. And 0 times 1 is 0. That the dot product is 0. 0, 0, 0 number. Therefore, that means it's the option A. When this situation happens, when the dot product is 0, because these vectors are orthogonal. So 90 degree. And it's obvious. So you see graphical, for example, in 2 dimensions. The vector B is here. 5, 0. Okay, 5 units, 1, 2, 3, 4, 5, and 0. And the vector W is 1 unit over. This is W. This is B. The angle in between this guy is 90 degrees. That is the reason that the dot product is 0. Make sense?
Yes.
2028. Dot product. Look at the vector B, 1, 2, and the vector W, que is 7, negative 1. And you compare the dot product. Multiplication component by component. So multiply 1 times 7 is 7. And 2 times negative 1 is negative 2. And 7 minus 2 is 5. It's important to understand, guys, that when the dot product, the answer is positive, like this and like that, that means that the angle in between the vector is acute. So less than 90 degrees. Otherwise, when the dot product is negative, it's because it's obtuse in the second quadrant greater than 90 degrees. Okay. And when it's 0, it's orthogonal 90 degrees. Okay. Let's practice now 29. 29 is a little bit more interesting because you need to find the angle. So the vector 9, the vector 29, sorry, vector B is 5,4. And vector W is 4, -2. And the goal is find the angle in between the vector. Okay, doesn't matter. The formula is theta is cosine inverse of some expression que involve in the top dot product B dot product W. Remember the symbolic way to indicate dot product is using this dot, pero bold dot. To differentiate is not regular multiplication, it's a special multiplication. And divided by magnitude B multiplication by magnitude W. And this is just a number, and this is regular multiplication. If you want to put another dot here, but no ball, to indicate it's a regular multiplication. Okay, let's do it step by step. B dot product W. You multiply 5 times 4, 20. And 4 times -2 is -8. This is 12. So far, we have cosine inverse of 12 divided by something. And magnitude is super easy. Magnitude is, for example, magnitude B is a square root 5 squared plus 4 squared. 5 squared 25. 4 squared is 16. Together is 41. Square root 41. And leave it like that for a moment. For a moment. And now magnitude W exactly the same. It's a square root 4 squared plus -2 squared. 4 squared is 16 plus 4 is 20. It's 20. And put together, this is square root 41 times 20, right? You can write separately 41 and square root 20, but you can condense it if you want in only one radical, no? Okay, the same. Either way. And you want, you multiply, why not? 41 times 20 is 41 times 20 is 820. So the multiplication, this guy, together, this and this together, is square root 820. Either way. Definitely, we're ending in the calculator, no? You put in the calculator, please help me to put in the calculator this cosine inverse of, and you declare in your own calculator, okay, you only need the answer in degree, not in radian. Be careful. Okay, the answer I get in my own calculator was 65.2 degrees. Get the option B. Any question?
No questions. That one was simple.
Okay. 30 is similar. It's a repetition the same. But let's do it because we need to practice. Number 30. Two vectors given. B vector is -5,7, W vector is -6, -4. What's going on? Entonces you perform dot product. B dot product W is 30 because -5 times -6 is 30 minus 28, no? It's 2. I might need to do each vector separately. Might need to be is square root -5 square. Be careful with the sign. The sign is always inside the square. Therefore, the answer is positive. And 7 squared is square root 25 plus 49 is 74. Leave it at that. And magnitude W. Oh, both are negative. I don't care. -6 squared plus -4 squared. -6 squared, 36. 16, 52. Okay. Now the formula is theta. It's the angle in between the vector. S equal cosine inverse of dot product 2 divided by radical 74 times radical 52. Put in the calculator like that. And it says 88.15 degrees. Like the option B, I guess so.
Sorry, Professor, can you come back to the 29, please? Because I didn't put the final result.
You see
Thank
both.
you so much. Yeah, I can see it. Thank you so much, Professor.
Okay, this is the question, the set of questions from 31st. 31st, 32nd, 33 is determines if the vector are well, no, 31st say read 31st. No, it's the same collection for the angle. It's the angle again. So 31 is similar to the 30, 29 and 30. It's the same. 31. But in this case, you apply different strategy because it's too easy. For example, the vector B is -3i. And the vector W is J. Okay, now.
Professor, 31 says V is a positive 3i.
It's positive. Okay.
Yes, it is
sure.
positive.
Nice. I copied wrong, but it's okay. The answer doesn't change. You see why? If you want, because you are not familiar with this notation and you prefer another notation, this is equivalent to say 3,0, no? Because we have no J component. And I is positive. Okay, it's positive. Let me fix it in my paper. Positive 3. Entonces in another direction. But it doesn't change because you see sometimes happen que W is I. Entonces I is 0,1, right? Okay, do you understand this or no?
No.
No? Bueno.
But where the 0 and 1 came from, Professor?
Okay. I alone, J alone is equivalent to C 0i plus 1k. Right? 0 is 0 and 1 is 1.
Okay, thank you. I got it.
Okay, and this one is similar. Look, this is 3i alone is 0j. And this 3 is this 3, and this 0 is this 0. Makes sense, right?
Yes, it does.
Okay. Now perform the dot product. 3 times 0 is 0, and 0 times 1 is 0. 0, 0 is 1, is 0. Therefore, it's 90 degrees. When you don't need to continue. No, when you see the dot product is 0, is because that vector are orthogonal, que es sinónimo to say que the angle in between that vector is 90 degrees. It's okay?
Yeah, that one was easy.
Yeah. The problem is to be familiar with the notation, because sometimes it's confusing. 32. 32 is the vector B, is equal 1, comma negative 1, and the vector W is 2, comma negative 2. So the idea is determine if these vectors are perpendicular o parallel. Entonces, the idea of the parallel, when you perform the problem, you get the number, right? Entonces, not clear. It's possible, but no, I prefer another way, another shortcut to do fast. How you prove the two vectors are parallel? Easy. You divide component by component. Divide. For example, you divide 1 divided by 2. So this 1 and this 2. And then you divide component by component. Negative 1 divided by negative 2 is negative 1 divided by negative 2. See, the answer is the same. They are parallel. Si the answer is not the same, it's not parallel. Entonces, bueno, okay, si no parallel, entonces you determine the angle using the formula for the theta. But in this case, theta is 0 degree. Or not exactly 0, 180 degree. Sometimes is, okay, let's try to understand geometrically, it's easy. Look, one vector is negative 1, 1. So one vector is negative 1, 1. So this vector is look like that. Each component is negative 1. No. I make a mistake. Hello. Okay, es 1, comma negative 1. 1 positive, the first component, and the second component is negative 1. This vector is like that. This is the vector B. And the vector W is similar, is 2 and negative 2. Is the only difference in between the vector is that the vector W is bigger, it's twice. So you can reformulate this idea. W is 2 times B. Because you multiply by 2, gets a scalar. 2 times 1 is 2, and 2 times negative 1 is negative 2. Do you see that? And geometrical is super clear, parallel. But the shortcut is you divide component by component. So you get the same result. In this case was positive half. Entonces now they are parallel. Okay. Do you follow me? Parallel?
Professor, I didn't understand where these 2 and negative 2 came from, because I see the problem is they just gave like the V. They didn't give us the W. I want to know where this came from.
What part? That part? That part?
No, Professor, like the W, it has equals 2 and minus 2. I didn't understand that part. Where these W and 2 and negative 2 came from, Professor. Because on the problem, it just gave us the V. It didn't give us the W.
No, Roland give me both B and W, no? And the challenge is, proof that they are parallel or no. Okay, entonces the shortcut do super fast. Suppose que you have two vectors, Noela. A1, A2. Another vector que es B1, B2. You want to prove that they are parallel, you divide, for example, A1 divided by B1 and A2 divided by B2, and see this is equal to each other, parallel. Otherwise, no.
But Professor, my question to you is like, we try like the options that we have on our paper, right? Because it has like a lot of options and we need to divide until we find the answer.
Yeah, I highly recommend that way.
Okay, thank you.
Divide. Everyone do it in the world. You prove that two vectors are parallel, you divide component by component, see the answer stay the same, it's parallel. And make sense geometrically, right? Because it's in the same line. Make sense geometrically, Noela?
Yes, it does, but dividing is easier.
Okay. Let me see 33. 33 is similar, look. 33. The vector B is 1,2. And the vector W is -1, -2. Okay, division. You divide 1 divided by -1, 1 divided by -1. This component and this component division. And this component division, que es 2 divided by -2. Es obvio que it's the same, no? Es -1. They are parallel. To see graphically, not necessary to do this, but to see graphically, look, the first vector is 1,2, 1,2, 1, 2. This is my first vector, B. And W is -1, -2. Do you see that these vectors are parallel? Of course, travel in opposite direction. That is the reason que es negative, completely opposite sign. Completely, the angle in between that vector is 180 degrees, no 0. But it's also parallel, right?
Right.
The connection, the formula is B vector is equal minus W vector. Because the only thing you should do is affect the sign, no? You multiply by -1 the vector W, you come back to the vector B or whatever you want. The vector B multiplied by -1, you go to the vector W. But it's parallel. So parallel travel, well, parallel, but not necessarily the direction. Parallel, no enforcing the direction. Maybe it's in the same direction or in the opposite direction, pero parallel. Good?
Good.
Okay. Okay. Let's see 34. 34 is different. 34 is, I suppose, que no parallel. 34 is B vector is 1,2 again. Wow. And W vector is 1/2, 1. Well. So you, for example, you divide 1 divided by 1/2, que es 2, no? And 1 times 2/1 is 2. And 2/1 is 2. Wow, it's parallel. This is a fantastic way to prove that. You divide components. So you divide, for example, the first component of the first vector divided by the first component for the second vector. And you divide the second component of the first vector and the second component for the second vector. See, the answer is the same number, parallel. Okay, super. Okay, now let's compute the, no. In 35, what should I do in 35? No, it's continuation, no? Okay, let me see. 35, 35 you prove parallel or orthogonal. Remember, orthogonal is 90 degrees. Okay, 35 is 35. The vector B is 4,1 and the vector W is 1, -4. Entonces you need to prove parallel or orthogonal. Entonces the fantastic way que I highly recommend is do using the dot product, no? You compute the dot product, que obviously is 4 times 1 is 4, and 1 times -4 is -4. If the answer is 0, orthogonal. Okay, and orthogonal is the weird word to indicate that the angle in between this vector is 90 degrees. Perpendicular. 36. 36 is a vector B. Is 2,3. And W is 3, -2. Again, let's try to do dot product. B dot product W is 6 minus 6 is 0. Again, orthogonal. 90 degrees. Now 37. The vector B is 4, -1. And the vector W is 8, -2. Well, in this case, it's obvious que it's not orthogonal because you multiply 4 times 8 is 32. 32 plus -1 and -2 is +2. Entonces 34, no 0, no orthogonal. But parallel maybe, if you divide component by component, for example, 4 divided by 8 and -1 divided by -2, see it's the same? Yes, of course, it's the same, 1/2. When you reduce in the Western 1/2 equal 1/2 because negative divided by negative is positive. Okay, parallel. More clear now?
Professor, if we do in the other way and we try to multiply, we're gonna have a different result. So it means that it's not orthogonal. We can do both ways.
Well. But however, not orthogonal, however, how you prove que es parallel. Okay, another way, Noela, look, let me show you. Suppose que you do in the dot product. The answer obvious is not 0 because no 90 degree is parallel. It's 32 plus 2 is 34, no?
Yes.
But this don't say clear si es paralelo o no. Es no 90 degree, no. Pero maybe es like this or like that. To continue, we can compute the magnitude of B. The magnitude of B is square root 16 plus 1, que es 17. Look here. A magnitude W is 64 plus 4, 68. And you multiply each other. Wow, let me see what is the answer. So 17 times 68. And is square root multiplication this guy. I get 1156. And the square root this guy is, let me try. Oh, unbelievable. It's 34. Entonces ese coincidence, 34 and 34. And you put in the formula cosine inverse, 34 divided by 34, que es obvio que es 1. And what is the cosine inverse que es 1? Is 0 degree. Parallel. Pero this is super easy way, coño. Right?
Yes, this one is easier. Yeah, I was just wondering if we have another form. Yeah, this part, this way is
it's frequently happen in mathematics. You have one easy way, shortcut. We have a complicated, but you get the same results. You are doing well in both directions.
Okay, thank you, Professor.
No problem, no problem.
Professor, could you zoom out? So
yes. Say. Guy, I am doing fast because of review, no?
Yes, but it's pretty simple, Professor.
Yes, thank you.
For you, Noela, remember, the terminology easy or hard is up the people. Okay, let me do 39, 30, 38, 39, and 40, and that's it. Okay, in this case, you compute the orthogonal components. But this is a more complicated idea. Let me explain clear. What is the idea? The idea is you have two vectors. You have two vectors. The vector famous B and another vector W. And the idea is break it down this vector in two components. One component in the same direction of W, que is called B1, and another component perpendicular, que is B2. So basically, the idea is break it down the original B vector in two components. And what is the characteristic of this component? B1 is in the same direction of W, and B2 is orthogonal, so 90-degree formulas. So what are the formulas? No formulas, in my opinion. No. Okay, the procedure is clear. You can write formula, but the formula is horrible and nobody understands very well. However, the concept is clear. If you perform, so you first of all, step one. Step one is you find the univector and the direction of W vector. This is easy. You take the vector W, you find the magnitude of the vector W and divide by this. I want to call this guy univector of W. What means that? That means we have a short little vector que the magnitude is 1, so the magnitude of the unit vector is 1, but in the same direction. So what is the reason? The reason is because this unit vector point in the same direction of W. Okay, so far everyone follow me?
Yes.
Step 2, you compute the dot product in between B vector and unit vector in the direction W. And I want to call this guy component. Component what? Oh, scalar projection is the component of the vector B onto the direction W. This is the symbolic way to indicate. This is a scalar. Scalar, it's obvious, no? Because dot product give me a number. And what is that? This is the length of that segment. Pero no vector, it's a number, 40, 20. Step 3, well, see, I want to find B1. Yeah, I know the length. Multiplication B1. Multiplication, so B1 vector is equal component vector, component scalar, sorry. So this number, multiplication, no special dot product, multiplication, just multiplication by the unit vector in the direction W. Do you understand this idea?
Yes.
And this give me the vector B1. Okay, using the two components because it's two dimension. And finally, the step 4, get the last one in the story. In order to find B2, you subtract vector B, get the original vector is given minus B1, and give me the orthogonal projection, 90 degrees. End the story. No formulas. Following this procedure. 1, 2, 3, 4 step. Okay, let's do it. Example 38. The vector B is given. Okay, 1,9. The vector W is given. Okay, it's 1,1. Okay. According to this step, we compute the unit vector. But to find the unit vector, we need first the magnitude of the vector W. Because square root 1 squared plus 1 squared is radical 2. And you find the unit vector in the direction W like that. You take W and divide by that. So you put 1 over radical 2 divided by that, comma 1 over radical 2. So you divide component by radical 2. Leave it like that, or either way, doesn't matter, rationalize. You rationalize, you get the answer. Radical 2 over 2, comma, radical 2 over 2. So far, everyone follow me?
Yeah.
I finish the step 1. The step 1 is compute the unit vector and the direction that you want to project in. Now, the step 2 is, in my opinion, the most important, is dot product. Dot product between vector B, dot product unit vector. Unit vector and the direction of W que es 1,9 dot product radical 2 over 2, comma radical 2 over 2. So I did my paper, well, it doesn't matter. I did my paper, not like that. I did my paper like that. It's the same. No? I copy 1 over radical 2, comma 1 over radical 2. And the dot product super easy. 1 times this is 1 over radical 2, plus 9 times this is 9 over radical 2. And this is 10 over radical 2. And now, if you want, in this moment, rationalize. Radical 2, radical 2, f5 radical 2. Because radical 2 times radical 2 is 2, and 10 divided by 2 is 5. And this is the top one. And that 5 radical 2 is the length of the vector b1. In order to find the vector b1, okay, I understand. You take that number, get 5 radical 2, and multiply by the unit vector in that direction. Okay, is 1 over radical 2, comma 1 over radical 2. Let's do it in the multiplication. So this is not the product, this is multiplication. Scalar time vector, so it's easy. Is 5, 5. Because when you multiply this, radical 2 is cancelled and radical 2 is cancelled. 5, 5. And B2, wow, guess the last step is B minus B. B, who's B? 1,9 minus 5,5. Entonces is 1 minus 5 is negative 4. And 9 minus 5 positive 4. That's it. Do you understand this one?
Yes.
Okay. One way to verify that this is everything okay is we come back at the beginning, you add in B1 plus B2. And the answer, obviously, we get B. Is 5 minus 41 and 5 plus 49. So we go backward, no? That one. Another way to verification, you are doing the dot product between B1, dot product B2. This is double checking, you know. So say you multiply is negative 20 and positive 20. Oh, it's 0. And indicate perfectly that B1 and B2 are orthogonal. So it's 90 degrees in between. This is matching perfectly with the idea at the beginning. Make sense?
It does. It does.
Okay. We practice a couple more of the example, and that's it. We finish the semester. Question. I hear something. Come on.
No, I did by accident. Sorry, Professor. It was me.
Okay, no problem. Okay, now 39. 39 is same problem but different number. Is B vector is the vector 1,5 and W vector is 3,1. So basically you have two vectors in that kind of problem, no? This is the vector that you want to break it down into new vectors. And this vector, no. This vector give me direction in what you want to project. Therefore, that is a reason we start working with the vector in the direction. You compute, first of all, the magnitude of this vector. Is square root 3 squared get 9, 1 squared get 1 is like that. And you divide, so the unit vector in the direction W is equal 3 radical 10, comma 1 over radical 10. So I highly recommend leave it like that. Because the rationalization we are doing in the last moment. No, not necessary now. Because you complicated your life. No. Now, the next step is perform the dot product between the vector B you want to decompose and the unit vector in the direction W. Es 3 radical 10 times 1 plus 5 radical 10. Entonces es 8. 8 over radical 10. This is the moment que I rationalize. Radical 10 es 8 radical 10 divided by 10. You reduce en lowest term, es obvio que es 4. Divided by 2 is 4, radical 10 over 5. And this is the component. This is the length of the vector B1. In order to find the vector B1, you multiply B1 vector. You multiply this number, is a scalar, 4 radical 10 over 5, times the unit vector and the direction is 3 radical 10, 1 over radical 10. This is the easy way, guys. So now it's obvious that this radical 10 is cancelled. And we have 12 over 5, comma 4 over 5. Because 4 times 3 is 12 over 5, 4 times 1 is 4. And this is the famous B1. In order to find the famous B2, you're subtracting B minus B1. And B is 1,5 minus 12 over 5, comma, no minus, comma, 4 over 5. Entonces we have -7 over 5. Where come from -7? Well, this is 1, que in my mind I suppose like a 5 over 5, in order to find the least common denominator. Entonces 5 minus 12 is 7, and here is 25 over 5, and minus 4 is 21. 21 over 5. Do you understand where I come from that number? I do in details. So 1 minus 12 over 5, LCD 5. This is 25. Where I come from? 5 times 5. 25 times 5 is 5. Let me see. Is 5. 5 minus 12. And 5 minus 12 minus 7. Likewise, 5 minus 4/5. 5 is 25 now, minus 4. 21 over 5. Okay, the answer is this vector B1. Okay, B1 means the component. So basically, the idea was decompose B vector into component, and the vector B1 is the component in the same direction of W. And B2 is orthogonal with W. If you perform dot product in between the vector, I suppose the answer is 0. Let's do it by curiosity. Suppose I am doing the perform B1 dot product B2 is 12 times 7 is 84, negative 84 over 25, no? Because it's 5 times 5. I am doing the multiplication, this guy times this guy. And the second is plus 84 over 25. The answer is 0. And this is suspecting that they are perfectly clear. Super easy or no?
Yeah, it has a lot of work, but it's not complicated.
No. See, I copy the formula. The formula is horrible. Nobody understands very well. However, I create like an algorithm, step by step, 4 steps. Step 1, compute the unit vector in the direction you want to project. Step 2 is perform the dot product, and you have the component. Step 3 is determine B1, que is the multiplication, no dot product, regular multiplication between the component number, que is just a scalar, and the unit vector in the direction of W. Boom. And B2 is orthogonal, but you determine subtraction. That's it. 40 is the last problem in this semester. Wow. We need to celebrate this, right? Okay, B. B vector is negative 3,4. And the W vector is 3,1. Okay. Let's do it. Magnitude W. Magnitude W is square root 9 plus 1. Wow, I did before this number, 10. Unit vector W. In the direction W is 3 radical 10, comma, 1 over radical 10. I'm not rationalize now, please. Okay, now perform dot product. Now perform dot product B, dot product unit vector in the direction W. So basically I am doing dot product minus 3,4 dot product 3 radical 10, comma 1 over radical 10. And the answer of that dot product is negative 9. Negative 9, radical 3, radical 10, sorry. Because negative 3 times positive 3 is negative 9. Plus positive 4. Okay, radical 10. And you're subtracting, it's negative 5, radical 10. This is the moment to rationalize. Entonces, radical 10, radical 10. Entonces, negative 5 times radical 10 divided by 10. And reducing lowest term is negative radical 10 over 2, no? Wow, I like that. Negative 10 over 2. Negative. When the dot product is negative, that means the angle in between that vector is greater than 90 degrees. It's obtuse. But I don't care. It's not important. Now for finding B1, you multiplication. Multiplication what? Multiplication. This number gets negative radical 10 over 2 times the unit vector in the direction W, que is 3 radical 10, square root 10, comma 1 over radical 10. Entonces, this is unbelievable, but it cancels this and this and this and that. And the answer is negative 3 over 2, comma negative 1/2. Both are negative because the reason is this number is negative, no? Okay, and the components are positive. When you multiply by the negative scalar number, both components are negative. And B2 is B, que B is negative 3,4 minus this component que es negative 3/2, comma negative 1. Be careful with the sign. It's tricky. So basically is minus 3 plus, because this negative together is positive 3/2, comma 4 plus 1/2. Well, this is LCD es 2, entonces es negative 6 plus 3, ¿no? Es negative 3. Ok, entonces negative 3/2, comma something, and this LCD is 2, this is 8 plus 1 is 9. 9 over 2 is positive, no? And this is B2. B2 and B1. Decompose. Right? Super, fantastic or no?
Yes, Professor. Can I take a picture?
Go ahead.
Okay.
Bueno, guys, entonces, let me repeat again. The important thing is, remember today is due test number 4 on paper and online. You submit, don't forget. Tomorrow in the morning, I will grade that. And the student can make a decision to take the final. The final is due this Thursday, April 28th. After this day, I don't care if you are sick, you are Probably no. I need to close my grade. And it's super complicated to fix it one grade. So you try to do your best, okay? What do you think about this semester? Was good or no? Or was hard? Was you, for example, you recommend to another student take with me this class or no? Too hard, eh?
Yeah, it's not you, Professor. You explained very well. It's the class. The class is hard, but not you. You explained well, Professor.
Bueno, entonces, the class doesn't change. This is no the variable that you include in the equation. You need to take hard class. And you take with me, recommend or no?
Yes, Professor, of course.
Well, entonces, Noela and another student, si you believe this idea, express your comment and rate my professor.com. I appreciate so much that.
Yes, Professor, you have good reviews there. This is where I found you. When I go there, I saw your name.
No. Okay, listen. This is the popular webpage in which the student can love me, express good comment, but there are students can hit me. Okay, so the good guy express a good comment, but the bad guy express a bad comment. Okay. Oh, yes. So it hit me. Yeah. He said, no. This is a okay. Trust to me. Yes. Okay, guys. See you soon. Remember calculus with me. No, I don't guarantee the fall. But the summer I guarantee tutoring, right?
Right.
Okay.
So, Professor, before you go, I'm just wondering, like we have graphs.
Noela, we are in touch. You email me. You say I say yes or no.
Professor, I sent you an email. If you could please check.
Okay, don't worry. Lianet, no?
Yes.
Okay, I read that. Bye, guys.
Okay,
Bye. Thank you, Professor.
Bye.
Thank you.